Example 7. Determine algebraically whether the function is even, odd, or neither. So in this example, we have three different functions that we have to algebraically determine whether the function is even, odd, or neither. So this is nothing more than a flashback to section 2.1. We're doing an algebraic test for symmetry. So if we're trying to figure out if the function is even, okay, that means that the function is going to have y-axis symmetry. And so the test would be, if we start with a point xy, then since we're testing for y-axis symmetry, y would stay put, and we're going to replace x with negative x. And then if we were testing to see if the function is odd, that means we're testing the function for origin symmetry. So if we start with a point xy, then we have to replace both variables. We have to change x to negative x and then y to negative y. Okay, so again, this is nothing more than a kind of a review from section 2.1. Okay, so we're going to try it on all three of these functions. Okay, remember, we are dealing with functions here. So since, anytime you're dealing with a function, it is not possible for a function to have x-axis symmetry. Okay, so you don't have to worry about x-axis symmetry, just y-axis symmetry and origin symmetry. Okay. All right, so let's get started on the function in example A. Okay, so remember, I recommended that you start off, before you do any of the testing, you rewrite the equation, or in this case a function now. Get rid of the exponents, break it down. Okay, also, now that we're dealing with functions, there's one more thing you have to do before you start testing. Okay, remember, when we get to origin, when we're testing for origin symmetry to see if the function is odd, we are going to have to replace y with negative y. Well, when you read the function in example A, it says f of x is equal to negative 3 times x squared minus 5. Where's the y? I don't see a y physically there in order to replace y with negative y. Okay, so if you're dealing with a function, you need to remember that f of x is the same thing as y. Okay, so for this function, before we even start testing, we are going to rewrite it. F of x is the same thing as y. Now we physically see a y, and y is equal to negative 3 times x squared. We're going to break down that exponent. X squared is the same thing as x times x. Okay, and then you'll have the minus 5. Okay, so going forward, this is how we want to work with the function. Okay, all right, let's first check to see if this function is even. Okay, meaning, does it have y-axis symmetry? Okay, so the test here is, if we start with any point xy, since we're testing for y-axis symmetry, we're going to leave y alone and change every instance of x to negative x. Okay, so let's give it a shot here. Okay, so here we go. Go to the boxed function here. Okay, so we're going to leave y alone. Okay, and then we're going to have negative 3 times, instead of multiplying by x, we're going to replace x with negative x. Okay, we have two instances of x that we're multiplying together, so this is going to be negative 3 times negative x times negative x, and then you've got the minus 5. Okay, so we've made the replacement. Now we need to simplify to see if we get the original equation back. Okay, so let's simplify. This is going to be y equals, we've got to simplify this part. Let's deal with the sign first. Negative times negative is positive, times negative is going to give us a negative. And then we've got the 3, and then x times x is x squared. Okay, so negative 3 times negative x simplifies to be negative 3x squared. Okay, don't forget the minus 5. Okay, so we have simplified. We need to compare to the original function, which is up here. Okay, so remember, f of x is y. Okay, so we simplified and we got basically y equals f of x, which is negative 3x squared minus 5, back. Okay, so we simplified, got the original back. So since we got the original back, that means we conclude, yes, this function has y-axis symmetry. Okay, so this is the original function. So we will say yes, this is an even function. Okay, and you know what? You can check yourself on the calculator. Okay, if you go to a calculator and you type in the original function, okay, so you would go to y equals and you're just going to type in the function, so negative 3x squared minus 5. If you should do this. Do you see where my cursor is? There's this little window button that helps you adjust what you see or how much of the x-axis you see and what you see along the y-axis. This is the standard window, okay? So basically what you want to do, x min is the smallest x value you see and x max is the biggest x value you see. I typically go from negative 10 to 10 in the x direction, and the x scale just means how often you're putting a tick mark. Okay, I'm putting a tick mark every 1 unit. Okay, and then I did the same thing for the y direction. So for the y-axis, the smallest y value I want to see is negative 10. The biggest y value I want to see is positive 10. And then because the y scale is 1, I'm putting a tick mark every 1 unit. Okay, so this is a pretty standard window. Sometimes if you don't see your graph in this window, then you would have to adjust this window. Okay, all right, so we'll go ahead and graph. Okay, and you can see that we have this parabolic shape down here, and it appears to be symmetric about the y-axis. If we took our sheet of paper and we folded it along the y-axis, then this portion right here, if you can see where my cursor is, this right side of the parabola would lie on top of the left side of the parabola. So we do see that this has y-axis symmetry, so it is an even function. But again, since you are asked to do this algebraically, you do need to show the algebraic test for symmetry. You can check yourself on the calculator. Okay. All right. So we know it's even. I'm going to go ahead and write that down. Okay. Now I will give you a hint. If you are dealing with a function, if it's even, it's not going to be odd, and vice versa. If it's odd, it's not going to be even. Okay. Back in section 2.1, we encountered equations that were not functions. If you are dealing with an equation that is not a function, it is possible for the equation, the graph of the equation, to have more than one type of symmetry. But if you are dealing with a function, it's either going to be even or it's going to be odd. It can't be both, or it will be neither one. Okay, so essentially, since we know, we have shown that this function is even, we can go ahead and say it's not odd. But I will go ahead and show you the odd test just to kind of confirm that. Let me put that in a different color. So if we went along here and we were testing this function to see if it were odd, that means we're testing for origin symmetry. So again, for testing for origin symmetry, if you start with a point x, y, that means you need to make both replacements. You need to replace x with negative x and y with negative y. Okay, so if we go back to the equation in the box, what we're going to do is we're going to replace y with negative y, and then we're going to have the negative 3 times, we're going to replace both instances of x with negative x, and then don't forget the minus 5. And now we need to simplify to see if we get the original equation back. Okay, this is going to tell us that negative y is equal to, we've already done this part, negative 3 times negative x times negative x. That is the same thing as negative 3x squared. Okay, and don't forget the minus 5. Okay, you want to compare y equals to y equals. So we need to get rid of this negative y. All right, so we're going to multiply both sides of the equation by negative 1. Okay, so we're going to get on the left, negative 1 times negative y is equal to negative 1 times the both terms on the right. Okay, you're going to distribute that negative 1 to both of the pieces on the right side. So you make sure when you write this down, you put both pieces in parentheses. Okay, and now you'll be able to distribute. Okay, so if we simplify, we're going to get y equals negative 1 times negative 3x squared is going to be positive 3x squared, and then negative 1 times negative 5 is positive 5. Okay, so if we compare our simplified equation, which is y equals 3x squared plus 5, to the original equation, which is y equals negative 3x squared minus 5, they are not the same equation. Okay, so I'm going to go ahead and say this is not the original equation. So this particular equation does not, or this particular function does not have origin symmetry. So we can say no function is not odd. Okay, so in conclusion, this function in part A, f of x is equal to negative 3x squared minus 5 is even only. It is not odd. Okay, you can see it from the algebraic tests. You can see it from the calculator. This particular parabola has y-axis symmetry. It does not have origin symmetry.